and formula weight anymore are pretty interchangeable. Now, it used to be that this term, formula weight, was reserved for ionic compounds, things like NaCl, things that didn't exist as a molecule, but more of that ionic crystal lattice, where that was hooked to that, and that was hooked to that, and that was hooked to that, that was also hooked to that, and it went in 3 dimensions. We had a whole bunch of stuff going on. Right, so we have this 3-dimensional crystal lattice. Formula weight is typically reserved, or should I say it used to be reserved, to describe an ionic compound, and this would be the formula unit. Now, the substance doesn't exist as NaCl. It exists as Na bonded to a bunch of Cl's and a Cl bonded to a bunch of Nas, but when you break it down to its most basic unit, we have formula weight. And then molar mass, that would typically be reserved for something that was molecular, something like CH4. And so now that was a long time ago, so you might be thinking, like, which one should I use? Aren't these AP graders going to be old? Won't they remember this? Yeah, they'll remember it. However, when in doubt, use the term molar mass. When in doubt, use the term molar mass. You're not going to get downgraded for not using the term formula weight. So what is a molar mass? Typically represented by capital M, and you will see that throughout this course. There are so many different variables, so many different terms that need to be represented by various equations that capital M is needed there for molar mass. Molar mass is the sum of all the atomic masses in a given chemical formula in units of grams per mole. Molar mass is always given in grams per mole. So if we go to your periodic table, and we look at all these masses, right? In terms of these molar masses, these are all in grams per mole. 1 mole of titanium has a mass of 47.867 grams. Right? And on and on and on. And there are several of them that you're already pretty familiar with. I bet you're pretty familiar with the idea that carbon has a molar mass of 12.011, oxygen pretty much 16. And by the way, generally speaking, these right here, these 3 are going to be very, very common to use on the AP exam. Also, with hydrogen, be very, very commonly used on the AP exam. When it comes to the multiple choice portion where you're not allowed to use a calculator, I suggest, for purposes of keeping yourself sane, even though you look at your periodic table, which you will have access to during the exam, even though it might say 15.999, right, which is truly more accurate, it's closer to the actual molar mass, you know what, let's not use that. Let's use 16. It's not quite as accurate, but it's a lot easier to wrap your head around that number. And you will be going to have to use your brain to do calculations with that. And you will have to do calculations with that. That times 4, that times 5, that times 6, things like that. And so making it easier on yourself by rounding just a little bit is going to be the difference between you stressing out on a multiple choice question and being able to use what you know and get that point. Empirical formula is the ratio in a network of an ionic substance. So going back to our image of this ionic crystal right here, the NaCl. So we have NAs and we have Cls. And we have a whole bunch of them. We have millions, if not billions, probably trillions of NAs and Cls. But when we reduce them down, when we reduce by the largest common factor, we see that we have 1 sodium for every 1 chloride, 1 chloride for every 1 sodium. So it's a 1-to-1 ratio. And so a 1-to-1 ratio would make the NaCl the empirical formula. It's a ratio. It's the ratio 1-to-1. Notice that these subscripts are both 1s. It's the ratio within that network of the ionic substance. Formula weight. Formula weight is the same as the molecular weight. It's just a language problem. Molecular, remember, implies covalent bonding, while formula implies ionic bonding. Just consider this to be a giant conspiracy designed to keep the undereducated from ever understanding chemistry. But you guys aren't undereducated. You guys are super educated, so no problem. No problem there. But like I said, when in doubt, just use molar mass. Okay, you do not need to use the word formula mass. Right? If you use the word molar mass, you'll be a-okay. Now, one more word about sig figs. Remember, we covered this at the beginning of our year 1 chemistry course. It is correct to pull numbers from the periodic table, the least number of significant figures of your molar masses as you have in your problem, right? General rule of thumb, just stick to 2 decimal places. Just stick to 2 decimal places. So you're going to have certain elements that are reported with more significant figures than others, right? Silver right here has 7 significant figures. Hydrogen has 4. Also, silver has 4 places past the decimal. Hydrogen has 2. Generally speaking, not generally speaking, I'm telling you right now, 2 decimal places will be fine for all your molar masses, right? Just keep it simple. We're not trying to, remember the AP graders are not going to grade you down because you were off by 1/100,000th of a decimal, right? You know how to do the process. You know how to do the calculation. This is not going to be a problem here. So you'll see as we do calculations here, coming from exercise 5, you'll see that if I were to use the number on the periodic table I just showed you, I would use 1.008 grams per mole. Or maybe you have a periodic table that says 1.0079 grams per mole. And this is more accurate than this. However, the difference is not so significant that we wouldn't get essentially the same answer if we used 2 places past the decimal. Or if I, the example of oxygen up here, I'm going to end up using 16.00. Again, 2 places past the decimal. It'll be good enough, A-OK, and it'll keep things simple for you.